We're very, very excited. So for those people who are on WebEx who don't know me, we have over 18 institutions joining us today from around the country. I'm Tamika Hayes. I'm the director of the Brain Imaging Research Center at the University of Connecticut. I'm also a faculty member, professor of psychological sciences. Professor Kimberly Noble, or Kim, is an MD and PhD. Like me, I'm very excited to see another one like me who's not in the med school, and is associate professor of neuroscience and education at Teachers College of Columbia University. She's a neuroscientist and a board-certified pediatrician, and directs the NEED Lab, which stands for Neurocognition, Early Experience, and Development Lab, where the state studies how socioeconomic inequality relates to children's cognitive and brain development. So she's very good at coming up with acronyms, such as catchy music. Just like many centers and labs here at UConn, I've noticed has great acronyms. She is supported by numerous grants, including 2 NA01s as a foundation grant that she's a PI on, as well as other grants. Dr. Noble received her undergraduate, graduate, and medical degree at the University of Pennsylvania and completed postdoctoral training at Weill Cornell Medical College. I was saying Weill. Yeah. Weill. She is a fellow of the Association for Psychological Sciences and was awarded the 2017 APS Janet Taylor Spencer Award for transformative early career contributions, among many other prestigious awards that she has received and probably will receive in the future. She is a highly sought out speaker. And this is why it's been taking us years to get her here, including a TED Talk that she has. And I just checked today because I remember you tweeting saying that it reached 1 million viewers, but it just reached over 1.8 million viewers as of today when I checked. And I know that since I was at UCSF, where I was faculty before, since 2016, we've been trying to invite her to come speak, and it didn't happen, but now it happens here at UConn, so I'm very excited. As I said earlier, we have over 18 institutions joining us from around the country. We're very excited. And those who are on WebEx, if you don't mind, please do confirm that you're muted. And then also, if you have questions or if you have any problems, please type in the chat box. If you would like to ask directly, then let us know as well, but we'll take questions later if you have some time. So it's a great honor to have you here, and thank you very much.
Thank you so much, Tamika, for that very generous introduction, and thank you to all of you here present today and to those of you around the country tuning in. This is not.
Was moving a minute ago.
Technical difficulties. How do you start over? Yeah, it worked earlier. I do it with the keyboard. Okay, now it's all right. All right, sorry about that. Okay. So, I think most neuroscientists would agree with the statement that early experience shapes brain development. And it turns out that the brain is arguably most plastic early in childhood. But, of course, a child's experience varies widely as a function of his or her family's social and economic circumstances. And so we can use social and economic factors as a lens through which to better understand early brain plasticity. So, taking a step back to make sure we're all on the same page, what is poverty? Well, in the United States, poverty is defined by the federal government as an income level defined by family size and composition, meaning the number of adults and children in the home. Interestingly, it doesn't vary geographically. So a family of 4 living in New York City has the same poverty line set for them as a family of 4 in Hartford, Connecticut, even though, of course, the cost of living is quite different in those two places. Now, currently, for a family of 4, the poverty line is set at just under $26,000 a year. And as you can imagine, trying to raise a family of 4 on that amount, particularly in a high cost of living area, that's pretty challenging to do. And yet, poverty is quite common, currently impacting more than 1 in 5 children around the United States. And as you all know, growing up in poverty puts kids at risk for a host of negative outcomes in terms of their physical health, mental health, and school achievement. Now, another definition, when I talk about socioeconomic status, or SES, I'm talking about more than just poverty. So I just told you that poverty is strictly defined based on family income, whereas SES comprises income, but other family characteristics as well. Things like parents' educational attainment, occupational prestige, as well as subjective social status, or where one sees oneself on the social hierarchy. And it turns out that when childhood SES is conceptualized in this way, it tends to be strongly associated with a number of important cognitive developmental outcomes for kids. Things like attainment tests, grade retention, or whether kids are held back in school, literacy, IQ, and school graduation rate, to name a few. And in fact, the socioeconomic gap in achievement tends to emerge early and then widen throughout childhood. So the data I'm about to show you come from the British cohort study of 1970, which followed tens of thousands of children in the UK longitudinally from about age 2 to about age 10. And of course, you're not going to give a 2-year-old and a 10-year-old the same exact set of cognitive tests. So on the y-axis, we have cognitive performance in percentile, or where kids performed relative to their same age. So first, I want to draw your attention to kids who came from socioeconomically advantaged homes who started out at age 2, performing at the 90th percentile, outperforming 90% of other 2-year-olds. So those kiddos who came from higher SES backgrounds, who were high early scorers, tended to perform above average throughout the course of childhood. Next, I'm going to draw your attention to kids who happen to come from socioeconomically disadvantaged homes, who started out at the 10th percentile at age 2, so outperforming only 10% of other 2-year-olds. So those children who were from socioeconomically disadvantaged backgrounds, who were low early scorers, tended to perform below average throughout the course of childhood. So far, nothing I've shown you is too surprising. A bit more surprising, though, is what happened to what we might term the crossover. So next, let's consider kids who also started out at age 2, outperforming only 10% of other 2-year-olds, but who happen to come from socioeconomically advantaged homes. So those children who were from higher SES backgrounds, but who were low early scorers, actually rose in their relative ranking over the course of childhood, such that at age 10, they were performing at or even a little bit above average. And finally, and most disconcertingly, you can ask, what happened to those children who were outperforming 90% of other 2-year-olds, but who happen to come from socioeconomically disadvantaged? So those children actually fell in their relative ranking over the course of childhood, such that by age 10, family socioeconomic circumstance is actually a much better predictor of cognitive development than an early cognitive skills. And so, while I think this is a particularly dramatic illustration of the emergence of socioeconomic disparities over the course of childhood, it really begs the question as to what factors might be contributing to this gap. And of course, you also want to come up with many possible factors, right? Differences in nutrition, physical activity, differences in healthcare and access to prenatal care or perinatal complications, differences perhaps in prenatal drug exposure or environmental toxicants like secondhand smoke or lead, differences in the home learning environment or schooling or family stress. And to this laundry list and the many others that you all could likely come up with, I would say, yes, really each of them has been shown to contribute in part to the link between socioeconomic status and children's cognitive skills. So, how do we make sense of that? Well, one way is to recognize that so-called cognitive skill is really too broad of an outcome, right? By which I mean that traditional achievement measures like IQ or school graduation rates aren't specific in terms of brain function. Like there's no one high school graduation nucleus of the brain. So we can be much more specific in asking which particular cognitive skills and corresponding brain circuitry seems to vary the most as a function of socioeconomic factors. That, of course, is the neuroscience approach. As we all know, neuroscience teaches us that different structures and circuits in the brain support different kinds of cognitive skills. And so by using a neuroscience framework and applying it to these questions about socioeconomic factors, we can ask which core cognitive systems seem to vary the most according to socioeconomic characteristics. And so that was exactly the approach that my collaborators and I took more than 15 years ago now when we first set out to ask this question. And in the initial studies, we simply looked at behavioral tasks that we knew preferentially tapped into some neural circuits more than others. So the first studies didn't use brain imaging at all. They were just neurocognitive studies in in which we recruited socioeconomically diverse families with children ranging in age from kindergarten on up to adolescence. And we simply asked, in which core cognitive systems would we see socioeconomic disparities, and would we see these disparities similarly across the various systems, or would we see socioeconomic disparities preferentially in some outcomes more than others? And the results were actually remarkably consistent across the different studies. So from kindergarten on up through adolescence, what we found was pretty dramatic socioeconomic disparities in children's language development, with more modest but consistent differences in declarative memory, as well as certain aspects of executive functioning. And so this early work led to several ongoing questions that my lab is attempting to answer. So what are these? So number one, how do these differences in children's cognitive development relate to underlying differences in structure and function of their brains? Number two, just how early are these disparities detectable? So the initial studies started with kids as young as kindergarten, and we reasoned that if we're already seeing dramatic differences by the time kids start formal schooling, these differences must emerge earlier. So when? Number three, which experiences, particularly modifiable experiences, seem to account for these links, and is the answer the same for various outcomes? And number four, how can this work inform intervention? So we'll touch on each of these questions over the rest of the talk. So, number one, how do these differences relate to underlying differences in children's brain structure? So a few years ago, I had the good fortune of collaborating with the pediatric imaging, neurocognition, and genetics, or PING investigators, who at the time had done something really unprecedented, in that they recruited a sample of more than 1,000 children and adolescents from around the United States. These were kids ranging in age from 3 to 20, and they set out to ask, how does age relate to typical brain structural development? So what kinds of brain structural changes do we see as a function of age in this very large sample? Now, the PING study did not set out to ask questions about socioeconomic factors, but we were able to take advantage of the fact that these were 1,000 plus children and teens recruited from very socioeconomically diverse homes. So we were able to secondarily ask the extent to which family socioeconomic characteristics like parental education or family income relate to the structure of their children's brains. And there were several different aspects of brain structure that we were interested in looking at, one of which being the surface area of the cerebral cortex. And that was because past work by other labs has suggested that in many cases, a larger surface area of the cortex is often associated with higher intelligence in children. And so we asked the extent to which we would see links between family socioeconomic characteristics and children's cortical surface area. So just to orient those of you tuning in remotely, if anyone's not using the MRI images, this is the front of the brain, this is the back, this is a view of the lateral or side surface. Again, this is the front of the brain, this is the back, and this is a view straight down the middle or medial surface. And this is an average across all 1,000 plus children and teens. And so we set out to ask, where in the brain might we see links between socioeconomic characteristics and brain structure among the children? And the answer was nearly everywhere. So nearly across the entire surface of the cortex, we found that higher family income, tended to be associated with a greater cortical surface. But there were some regions, shown in yellow, where this relationship was particularly pronounced. And notably, those were areas like peripheral cortex, which is critical for language development, as well as parts of the prefrontal cortex, which are critical for executive function. So the neural data really recapitulated what we had previously found behaviorally. Now, there are a couple points to note from these findings. So number one, this link between family income and children's brain structure wasn't linear. Instead, it seems that the relationship is actually strongest among the most disadvantaged families. And so that meant that dollar for dollar, relatively small differences in family income were associated with proportionately greater differences in children's brain structure among the poorest families. And intuitively, that makes sense, right? An extra $10,000 for a family earning $200,000 a year would, I'm sure, be nice, but probably not make a dramatic difference in their day-to-day lives. Whereas an extra $10,000 a year for a family earning $20,000 a year would likely make a pretty remarkable difference in their day-to-day lives. And the second point, and this is really key, there was tremendous variability from one child to the next, by which I mean there were plenty of children from higher income homes with smaller brain surfaces and plenty of children from lower income homes with larger brain surfaces. So in no way could I know an individual child's family income and predict with any accuracy what that particular child's brain might look like. That's really important, right? And this paper got a fair amount of press coverage, and I would say that in many cases the press really got it wrong in that there were a number of headlines saying things like poor children have smaller brains. And we really can't overgeneralize that way. Stigmatizing and really doesn't accurately represent it. Okay, so you can say we do see clear links between family income and children's brain structure, but you might ask, well, does it matter? Right? I mean, you can't see a child's brain, so does it matter how it looks anatomically? So at least preliminarily, we think so. So in this study, differences in brain structure accounted for some of the links between socioeconomic circumstance and children's executive function. Other work by people like Pollock and John Gabrielli and colleagues suggests that these differences in brain structure account for anywhere between 15 and 44% of the income achievement gap. So moving on to the second question, just how early are these differences detectable? So spoiler alert, what we seem to be finding is that for behavior, we seem to be able to detect differences as early as the second year of life. And for brain development, we seem to be able to detect the first differences in the first year of life. So let me show you a bit of data to back up those things. So first, this was a study we did several years ago, looking behaviorally in a group of socioeconomically diverse families with infants and toddlers. And we followed these children longitudinally, either from 9 to 13 or 15 to 21 months of age. Now again, even from 9 to 21 months of age, those of you who have experience with young kids know that those has a pretty wide developmental range. So again, you're not going to administer the exact same test to different ages. So on the y-axis here, we've got language composite score with the unit being the mean score. So a score of 0 represents children who are performing at the mean for that age. And I'm showing you the data that we analyzed continuously, broken for display purposes into seasons. The blue line represents children of the most highly educated parents in the sample. The red line represents children of middle-educated parents in the sample. And the green line represents children of the least educated parents in the sample. And so what we found was that from 9 to 15 months, we're seeing pretty flat lines. Right? So we're not really seeing the emergence of socioeconomic disparities in language development just yet. But from 15 to 21 months, what we're seeing is that this blue line, speaking of the more highly educated parents, is rising to the top of the distribution. Whereas, unfortunately, the green line, representing children of less educated parents, is unfortunately falling to the bottom of the distribution. And it turns out this difference between the blue line and the green line at 21 months of age is not just statistically significant, but clinically significant as well, representing an effect size of about 0.8 standard deviation. So a large effect size statistically. Put that into context, that's equivalent in magnitude to about 12 IQ points. Now again, this wasn't an IQ test, it was a composite of language measures, but it nonetheless gives you a sense of how large the disparities already are before children even turn 2. And we found a very similar pattern for memory development. Again, by 21 months of age, we saw about 0.8 standard deviations of difference across groups in terms of their memory development. So, as I mentioned, the earlier images were taken using MRI, which, as many of you know, involves sitting perfectly still in a dark and noisy tube. It's great for adults and older kids. It can also be relatively user-friendly in very young infants. A bit harder as infants and toddlers get a little bit older and less likely to lie still without their caregiver. So to measure brain development in that age range, we pull out another tool in the toolbox, namely electroencephalography or EEG. Here involves this set of electrodes on the chest. And we can use EEG to measure the electrical activity of the brain by measuring the electrical activity at the scalp and then then the signal gets decomposed into different frequency bands that look like this. And broadly speaking, we know from past work from other labs that kids who are at risk for learning and attention problems in school often tend to exhibit a relative excess of low-frequency oscillations and a relative deficit of high frequency faculty. And so a few years ago, I had a trainee, Dr. Hadley Budo, who's now an assistant professor at NYU, who wanted to push the envelope and really ask just how early in life might we see socioeconomic differences in brain development. And so she used EEG in the first few days of life, so among neonates who were just a few days old, to ask whether we would see any socioeconomic differences in nesting brain function in the frequency bands of discussion. And her answer was a resounding no. So there was absolutely no evidence for any link between either parents' educational attainment or family income and resting brain function in any frequency band anywhere across the scale. Now, you might say, okay, well, that's fine, but who knows what's going on in neonatal brains, right? Maybe there's just no variability there. Well, that doesn't seem to be the case, right? There does seem to be variability, it's just not accounted for by socioeconomic factors. And then you might say, okay, well, maybe there's variability, but maybe that's just noise. Again, like, who knows what might be going on inside a neonatal brain? Maybe that signal doesn't mean anything. Well, that doesn't seem to be the case either, because among these same newborns, when we tested them 15 months later, we found that neonatal EEG patterns did predict 15-month-old cognitive skills. So it's not that there's no signal in this noise, it's just that the signal is not accounted for by socioeconomic. Now, while that doesn't necessarily rule in a postnatal cause, right, there are plenty of processes that emerge postnatally or decades later that still have a potential genetic or prenatal etiology, it at least suggests the possibility that the emergence of disparities may be rooted in postnatal. Now, we have been doing a few other studies looking a bit later in the first year of life, and in fact, we're finding that we do seem to be able to detect socioeconomic disparities in resting brain function sometime in the second half of the first year. So even though we don't see it very early on, we are seeing the emergence of socioeconomic disparities in brain function later on in the first year. All right, so moving on to the third question, what experiences might explain these differences? So I showed you this slide before. In my lab, we're particularly interested in a few of these experiences, namely the whole language environment and family stress. So I'm going to present you a theoretical model of what I think might be going on, and then I'll show you some data to support it. So the theoretical model goes like this. We know that there are socioeconomic disparities in the whole language environment, meaning the quality and quantity of words that kids are exposed to. In turn, we think that the home language environment is important for shaping the development of parts of the brain that support language. And simultaneously and relatively independently in the literature, we know that there are socioeconomic disparities in the experience of stress. We know from both the animal and human literatures that there are certain brain regions that are particularly sensitive to stress, like the hippocampus, which is critical for memory development, as well as prefrontal limbic circuitry, which is very important for self-regulation. So we're interested in testing this entire theoretical model among single cohorts of children.
Let me ask a question from the audience. What are your thoughts on there not being different EEG patterns at birth, given prenatal care and exposure differences by SES? That is, lead exposure, prenatal care, prenatal vitamins, and so on.
Absolutely. So it's not to discount the importance of the prenatal environment. So there are different possible explanations, right? Is our signal detector is just not strong enough. Maybe there are prenatal differences in other aspects of brain development that we wouldn't have been able to pick up using that EEG, but we might have been able to pick up from other methodologies. It's possible. An alternative explanation is that differences in prenatal care or the prenatal environment manifest later, right? So it's not necessarily the case that any differences in prenatal experience would be evident immediately after birth, but they might be evident down the road. And thinking a similar argument in terms of genetic predisposition, no one can measure likelihood of developing Alzheimer's disease, typically at birth, even though there certainly is a genetic predisposition to that, right? So I wouldn't want anyone to think that we ruled out genetic or prenatal causes just because we don't see differences at birth, but if we did see differences at birth, that would have ruled out postnatal experience etiologies, right? So at least we need to open the possibility that we're talking about differences rooted partially in postnatal experience. Good question. Okay, so what can I tell you about the top arm of the theoretical model? What do we know about socioeconomic disparities in the home language environment? So some of you may recognize this slide. These, of course, are the pioneering data of Hart and Risley, who in the mid-1990s followed typical families longitudinally for the first several years of their children's lives. Every month, they went into these homes, and for a few hours, tape recorded every word the child heard and every word the child said. They then brought their tape recorders back to their lab, where some poor graduate students had to transcribe everything. And what they found was that at every age, the children from the more socioeconomically advantaged homes heard more words than the children from the more socioeconomically disadvantaged homes. And so extrapolating that out over every waking hour over the first few years of these children's lives, the authors calculated that this amounted to a 30 million word gap in terms of the number of words heard from the more advantaged kids compared to the less advantaged kids. And subsequent work showed that it wasn't just the number of words, but also the complexity and the responsiveness, the back and forth conversational nature of the verbal interactions that varied along socioeconomic lines. You might not be surprised to learn that the number of words that the kids heard was directly related to their vocabulary size. Now, I showed you earlier that some parts of the brain where we see the most pronounced socioeconomic disparities in brain structure are parts that are known to support language development. And so we reasoned that perhaps these differences in the whole language environment might account for socioeconomic disparities in these regions. Now, we have it a bit better than Hart and Risley and their 4 graduate students in that we're able to use this device known as the LENA, or Language Environmental Analysis Tool. Basically a small digital recorder that fits into specialized clothing that the child can wear for up to 16 hours. The family then hopefully gives it back to us, and we're able to automatically upload the data, and the software computes the number of adult words the child heard over the course of that 16 hours, number of vocalizations that the child made, as well as the number of conversational turns or back and forth responsive interactions between the target child and the adult. And so what we found was that among a group of 5 to 9-year-old children, children who experienced more conversational turns had a larger surface area in this parasomnian region, which we know is important for language and reading development. And in fact, these differences in brain structure partially accounted for socioeconomic disparities in reading skills in this sample. And one finding that I thought was particularly interesting was that we did not find any link between children's brain structure and the number of vocalizations they themselves were making. And you might imagine, well, maybe it's just that chattier kids are engendering more conversations, and those chattier kids have different looking brains. That didn't seem to be the direction that the data would suggest. Instead, it really did seem to be the conversational turns driving the brain development, not the other way around. So, moving on to the bottom of the model, what can we say about disparities in the experience of family stress? So, it's pretty well established at this point that growing up in socioeconomic disadvantage is more likely to be associated with exposure to stress in terms of things like limited material resources, perhaps chaos in the home, perhaps violence in the neighborhood. And we know that when parents are distracted or depressed, that family life is more likely to be characterized by conflict and emotional withdrawal rather than the kind of nurturing and supportive parenting that we know is so important for children's development. Now, we and others have reported that socioeconomically disadvantaged children often have altered levels of stress hormones like cortisol. And as I alluded to earlier, we've got decades of work from both the animal and human literatures suggesting that there are certain brain regions that are particularly sensitive to stress and to cortisol, notably the hippocampus as well as prefrontal limbic circuitry. And so we reasoned that perhaps these differences in chronic stress might account for socioeconomic differences in those brain regions. So how are we measuring chronic stress? A few different ways. So we ask parents about their perceptions of stress, their experience of stressful life events, their experience of chaos, their mental health. And then we're also collecting stress physiology, both in parents and children. And in this case, we're measuring stress physiology by measuring cortisol in hair. So cortisol is more commonly measured through saliva, but I see a number of you nodding your head. So salivary cortisol collection poses a number of methodological challenges. Our salivary cortisol reflects our blood cortisol level, and that means that it starts out high in the morning and decreases over the course of the day. And the actual values vary quite a bit from one individual to the next. So and for that matter, from one day to the next, and in relation to lots of other factors. And so to really get a clear picture of diurnal cortisol variation, typically people take 2 or more measures over the course of a day or even several days. I don't know about 2, but if someone handed me, 9 cheek swabs or 9 salivary collection kits and told me to, measure my kid's saliva 3 times over the course of 3 different days, I would probably make a mistake. So we're able to capitalize on the fact that cortisol is chronically secreted into hair, and we can take a single small measure of hair one time in the lab, and if an individual has at least 3 centimeters of hair, then we can get an average level of cortisol over the last 3 months. And so we've been doing this for a few years now. We've shown that we do see socioeconomic variation. So here, I'm showing you that kids whose parents are more educated tend to have lower levels of their cortisol, and that holds even when adjusting for the parents' own cortisol levels. And more recently, we've shown that kids who have higher levels of hair cortisol themselves tend to have a smaller hippocampal volume. So in line with previous stress literature suggesting that higher stress is often associated with a smaller. This was driven by differences in the PhD and dentate gyri, so in line or in parallel with what the animal literature would suggest. And in fact, these differences in hair cortisol statistically mediated socioeconomic differences in hippocampal volume in this study. More recently, we've taken a look at stress physiology in relation to infant brain development. So here I'm going to show you results from a recent study looking at 6, 9, and 12-month-old infants. These were kids who came from socioeconomically diverse backgrounds, but here I'm controlling for SES, and really looking at differences in maternal chronic stress physiology, maternal hair cortisol. So for display purposes, I'm showing you a median split of infants whose mothers had high maternal hair cortisol and infants whose mothers had low hair cortisol. And I'm going to be showing you resting EEG, so to orient you, looking your head, noses, so imagine someone lying on their back with their feet pointed into the wall. And let me show you heat maps. So first I'm going to show you heat maps of theta or low frequency power. So if you recall, what I told you earlier was that work from other labs suggests that when we see a relative excess of low frequency power, that's often a signal that a child is subsequently going to have some difficulties with learning. We're going to look at the distribution of low frequency power as a function of maternal chronic stress. And so what you see is that infants, moms with high levels of hair cortisol, have quite a bit of low frequency power, in contrast to infants of mothers with low levels of hair cortisol. You see this difference where the infants of mothers with high levels of hair cortisol show quite a bit more low frequency power. Now I'm going to show you that of high frequency. So here, again, same median split into infants of moms with high levels of hair cortisol, infants of moms with low levels of hair cortisol, and here I'm showing you that of high frequency. And so here we see the opposite. So the infants of the moms with lower levels of chronic physiological stress show much greater representation, much greater proportion of high frequency. And this really recapitulates some of the findings found in samples with much greater adversity. So among infants or children who have been previously institutionalized, for example, we'll see the same. So far, I've tried to paint a picture whereby we think that socioeconomic disparities in children's experience, such as language environment or exposure to stress, plays an important role in the development of their brains and cognition. And if this is right, and experience matters, it begs the question as to whether this work can inform interventions, and if so, what's the right level at which to intervene? So theoretically, right, you could imagine intervening at anywhere along this pathway. So first, let's imagine what it might look like to intervene at what I'll call the most proximal level, at the level of cognition itself, which happens most commonly through school-based intervention. So certainly, school-based interventions are the most common form of intervention aimed at targeting socioeconomic. And there are lots of great examples of school-based intervention, some of which have very promising results. But as any intervention scientist will tell you, it can be challenging to implement high-quality interventions in schools. Right? It can be labor-intensive and sometimes costly. School-based interventions often suffer from a phenomenon known as fade-out, which is the idea that shortly after the cessation of the intervention, you might find differences between groups, but then if you go back to those same children 6 months or a year or 5 years later, often those differences fade away. And it's not to suggest that the intervention wasn't effective in the first place, but it does suggest that perhaps they needed a longer intervention or longer booster doses, which of course makes it costlier and more labor-intensive. Finally, while I would be the last person to deny the critical importance of high-quality early childhood education, I will say that if we're waiting until the start of formal schooling, we're probably waiting too late. You see pretty remarkable disparities before children even turn 2. So while school is going to have to be part of the answer, if we're waiting until kindergarten and pre-K, probably not going to be the whole answer because we're already going to be behind. So we're not taking a step back and trying to change children's experience. So outside of school, this would most commonly take the form of parenting interventions, which commonly, though not always, tend to be home-based. Again, there's a number of excellent examples of home-based interventions, many of which tend to be effective. Again, home-based interventions can be labor-intensive. They're sometimes costly. In addition to challenges around fade-out, it's often difficult to get families engaged in home-based interventions and then to retain them in studies, right? To some extent, if you're implementing a school-based intervention, once the school buys into the program, you've got something of a captive audience. Obviously, there can be differences in fidelity and implementation, but you've got a school who's bought into the intervention. Whereas, for the most part, for parenting or home-based interventions, typically are operating outside of that kind of infrastructure, so it's much more difficult to get families and to keep them in the program. And so I would say, it's one thing to bring a few dozen parents or families into a lab a few times a week over the course of several weeks or several months, but it's quite another thing to try to scale up those kinds of interventions to the community level or beyond. Not to say it's not possible, it's just a great challenge for us. And so, for the rest of the talk, I want to challenge you to think about what it might look like to intervene at the most simple level, at the level of socioeconomic disparities themselves. The work by my social science colleagues suggests that relatively small differences in family income can be associated with relatively larger differences in outcomes for children. So based on the correlational literature, we know that a $4,000 difference in annual income in the first several years of life is associated with differences for those kids later on. So improved school achievement, increased adult earnings when those children grow up, increased time spent in the labor force, and even some evidence for improved health in adulthood. Of course, as good scientists, we all know that correlation is not causation, and so to ask whether it might be possible to move past correlation to understand whether income is actually causing these differences. There are plenty of people who would say, well, poverty isn't causing these detrimental outcomes for kids. For example, whether you're willing to put yourself up in the We might have different responses to that, but from a scientific perspective, without a causal study, it's very difficult to respond definitively one way or the other. And so that's really the basis for the BIRC Speaker study, which is the first clinical trial of poverty reduction in early childhood.
Can I ask a question about income, increasing income? And I may have missed this one. I'm a little distracted here, but you said $4,000 an increase leads to a lot of these different improved outcomes.
It should be different. So this is a positive correlation.
Right? So it's correlational. So we still don't know if it's the other things that are involved that's associated with $4,000.
Based on the correlational literature, we can say that
it could be the parental attitude, it could be the nutrition, it could be the books that they purchased with the extra dollars. So it could be a lot of different things.
Lots of different things. And things that are extrinsic to them.
Right.
Okay. So who are we and what are we doing? So I've been really privileged to work with an amazing interdisciplinary team on this study for the last 7.5 years, led by social scientists Greg Duggan, Catherine Magnuson, Lucy Janetian, and Taylor Yoshikawa. I was the neuroscience arm along with psychology and what are we actually doing? So in the last year, we recruited 1,000 low-income mothers shortly after they gave birth at a number of hospitals around the United States. All mothers, upon enrolling in the study, receive an unconditional cash gift every month for the first 40 months of their children's lives. But mothers are being randomized to either receive a large monthly cash gift, $333 a month or $4,000 a year, or a nominal monthly cash gift of $20 a month or $240 a year. And so how do we pick those amounts? So I told you a moment ago that correlationally, $4,000 a year is an amount that has been associated with improvements per kid. So it's an amount that we think is plausibly likely to move the needle. And importantly, it's also a policy relevant amount. Right? So this is in line with other social services and benefits that low-income moms might qualify for, like food stamps or the earned income tax credit. Put another way, even if we put in some money to give every family $50,000 a year, that's unlikely to be translated into so we administer the cash via a debit card that comes preloaded and then automatically reloads every month on the monthly anniversary of the child's birthday. And so in this way, we're going to be able to estimate the causal impact of poverty reduction on children's cognitive, emotional, and brain development over the first 3 years of life, which is the very time that as neuroscientists we believe that the developing brain may be most malleable to. So we completed recruitment this past May. We're currently in our first phase of amassing impact data as the children are turning 1. So they're turning 1 over the course of this year. So unfortunately, I don't have impact data to share with you yet, but hopefully I'll be able to come back and share with you.
You have to get it in writing.
All right. So how do we think these extra economic resources are likely to benefit these families? We've got 2 main pathways that we're proposing. One is called the increased investment pathway, and that's the idea that with greater economic resources, moms are more likely to be able to buy more books and toys and trips to the museum, also potentially higher quality child care, maybe better housing and better neighborhoods. And the other we're calling the reduced stress pathway. And that's the idea that if moms are less worried about how they're going to make their monthly rent check or keep the lights on, they're more likely to have the bandwidth to make good decisions for their families. They're more likely to be able to engage with their kids in the kinds of warm and nurturing ways that we know are so important. Now, chances are both of these pathways are active, perhaps differently in different families. And so although we're measuring the pathways very carefully, our ultimate primary hypotheses really rest on the impact of the children. So briefly, what are our data collection plans? So when we were recruiting the moms in the hospital, we administered a survey to better understand family composition and family life. As we're going, as the children are turning 1, we're visiting the families in their homes, again administering a survey. We're also observing parenting and video recording parenting to code mother-child interactions and child behavior. We're collecting maternal stress physiology through the care protocol, some very basic measures of children's language and social emotional development. And we're also using portable EEG to measure children's brain function at age 1. At age 2, we'll be doing a very similar battery, again visiting the families in the home, adding on epigenetics to understand experiential related differences in genetic expression. And then finally, at age 3, we'll be inviting families to the lab to do a complete assessment of children's cognitive, emotional, and brain development, as well as, again, measuring maternal and local child stress physiology and administering a survey. So a few few years ago, we completed a pilot study basically to understand whether it would be feasible to recruit moms, to retain them in a study like this, for them to access a debit card. We were pleased to find that it did seem to be quite feasible. So we did this with 30 low-income moms in Colorado, New York City. We were pleased to find over 93% retention over the course of the pilot. And importantly, very few problems with debit card use. And that was important because it was the first time ever using a debit card for more than 1 in 5 moms in the pilot. We also embedded a qualitative study in the pilot, which we're doing as well in the larger study. And this allows us to interview moms and get some richer understanding of how these increased economic resources impact their day-to-day lives. So a few quotes from the pilot work. One mom told us, believe it or not, we did an extra $20 help. There were times I found myself completely broke. I go and I use it, and that means I can use it for another week. And another mom told us, the money from the card really, really helped me out. Especially one month that we didn't have the food stamps, we didn't have anything. Now, most moms told us in the course of these interviews that they were using the money for the baby. But because we're administering the cash on debit cards, we don't have to take the mom's word for it. They give us permission, we can track the transactions. And this slide shows you that over the 1,112 transactions that took place over the course of the 1-year pilot, there were roughly 3. I've got some very hot off the presses first look at the ongoing transaction data from the larger study. I apologize that it's oriented differently. But again, very similar distribution of expenditures. Again, with very few taking place in the store for adult places. Control group is receiving $20 a month. I'm going to treat it as a big control group.
Were they told that they would back down?
Yes. So we only track them if they're correct. That's absolutely right. Right. So we only track the money if they give us permission to do so. Right. So there are some people who have opted into the study but declined transactions. That's fine. Similarly, we can't track money beyond ATM. We do ask them quite a number of questions about expenditures. So we've got some female economists on the team who have been, studying expenditure data for a good portion of their careers. And so to the extent that survey data are reliable, we're asking the right questions to try to understand how families are spending money, but we can't track it beyond that. Similarly, money is fungible, right? So even though it's an unconditional cash transfer, mothers are free to spend it however they like, they still might rationalize and say, well, if they're watching me, I'm going to use this money for diapers and something else for other things, right? So we can't really get beyond the first use of the debit card, but we can ask them what they're doing. In the pilot data, again, as I mentioned, I don't unfortunately have outcome data to share with you yet for the larger study because we're collecting the data. But that's for the pilot data, our first glimpse, which you should take up with a grain of salt because it was only 30 months. But we did see that the intervention group showed preliminary benefits relative to the control group in terms of higher reports of center-based child care expenditures, more frequent reports of mother-child activities, and lower reports of household chaos and parenting. And so, if we're right and reducing poverty can change children's trajectories for the better, it begs the question as to what might be the policy impact of work. And so, in this slide, I'm showing you that the United States really pales in comparison to our developed country peers in terms of the size of public spending on children. But it doesn't necessarily have to be this way. So here, I'm showing you with the blue line, rates of poverty for senior citizens since the late 1950s. What we see is that back in the late 1950s, senior citizens were living in very high rates of poverty. More than 1 in 3 seniors were living below the poverty line. But with the advent of social services like Medicare and Social Security, that number slowly fell to the fewer than 10% of senior citizens living in poverty today. In contrast, back in the late 1950s, around 1 in 4 children were living in poverty. The number was reduced somewhat by the advent of Medicaid. But because spending on families with young children has not been a historical priority of our government, that number has steadily risen to the more than 1 in 5 children living in poverty today. And so it's our hope that by systematically testing the causal impact of poverty reduction, will provide some direct evidence of the effects of poverty reduction on the developing mind and brain. And in turn, that this will inform debates on both the generosity or cuts to new social service programs as well as existing social service programs that impact millions of disadvantaged families. So there are many programs like housing vouchers and food stamps that are continually on the chopping block on Capitol Hill. And so it's our hope that this study will inform the wisdom of those types of services, as well as various other programs that are frequently in the news, like paid family leave or the minimum wage. So while I would never suggest that income is the only or even the most important factor in determining children's brain development, it may be one that's particularly manipulable from a policy perspective. But I thank you for your attention. You can follow me on Twitter, @Jam. If you want to see the same talk in 12 minutes, you can otherwise, thanks to my environment, team members, collaborators, and generous funders, and I'm very happy to take any questions.
I think it's really, really interesting. And I'm particularly excited about hosting. I'm particularly interested in the environment. And I wonder, in the data that you have collected so far in the early study, have you looked to see does cortisol influence language areas, or does input levels influence later stress levels? So have you tried to solve those?
So it's a great question, and you know, certainly one would expect that they're not really as orthogonal as I suggested in the theoretical model, right? And you can imagine lots of reasons. A stressed out mom may talk to her child less because she's distracted or depressed. So that's highly likely. We've at times found some hints of that, at other times not. We actually recently launched a longitudinal study, a neuro one, looking longitudinally from the prenatal period through age 3. So we're really going to be able to use longitudinal modeling to try to understand the temporal patterns and what may be accounting for that. Stay tuned.
There's a question in the chat.
Great. Okay.
Kind of a long one. Referencing some steeper decline as seen in results on household income, particularly the lower SES end and brain surface area in your 2015 paper, and from your theoretical model that childhood SES is linked to home language environment and to stress, would the children's brain cognition development be further hindered if exposed to deficit/deprivation in both of these components that are often related to lower SES households? For example, verbal chaos may be linked to both socio-emotional stressors, household chaos, and perhaps poorer quality home language environment. Would these further exacerbate delayed brain cognition development, given that executive and socio-emotional functions and language growth partly go hand in hand, and that since these brain regions that support these cognitive abilities individually talk to each other throughout development?
Yes. So it's a great question. I think it is sort of asking a fundamentally similar question in that aren't these arrows bidirectional? Aren't the outcomes influencing the proximal characteristics? I think almost certainly, right? It's why it's very hard to disentangle these mechanisms. So many things are correlated with other things. And so part of the answer will at least be hinted at through the longitudinal study I just mentioned, where we'll be able to track temporally what's preceding what. The best answer, of course, is an experimental design using an RCT, where you manipulate one of those factors and then see what the downstream impact are.
I'm also interested in knowing more about multilingualism as a possible aspect of some groups' home environment. I believe, if I'm not mistaken, the LENA system is not going as a way to distinguish between the languages. What I think you can possibly get reporting and there'd be ways to code for it. Also, I wonder if you were selecting multiple parents.
Sure. So it's a really important question, right? Because in the United States, bilingualism is often confounded with socioeconomic disadvantage. So interestingly, in other countries, that's not always the case, right? So there's been a number of examples of research suggesting a bilingual advantage for certain things, most notably executive functions, but some others still too. That's not always found, and there's some thought that there may be confounds. So Natalie Rito, who I mentioned earlier, is very interested in this, and is conducting an R01 right now to really make sure that all four cells are well represented to try to disentangle what bilingualism is. That said, you asked about what we have found. So in some studies, we expressly recruited monolinguals to avoid the issue. In others, we've controlled for exposure to second language. And I can say in our work, it's, to the extent that it's disentangleable, we see much smaller effects of bilingualism than we do.
A little bit about changes in alpha that are related to cortisol. Can you just talk a little bit more about what you think that might reflect?
Yeah. So there's been a fair amount of work looking at a so-called maturational lag. So I guess I should take a step back and say, in general, as infants get older, you see proportionately more higher frequency and proportionately less lower frequency power. Everybody has everything, but that's the growth, if you will. People talk about a maturational lag, where if you see, compared to same age peers, if you see proportionately more low frequency power and proportionately less high frequency power, that tends to be associated with worse cognition. That pattern, that so-called maturational lag, has been described among kids exposed to extreme adversity, like institutional trauma. Here, we found sort of garden variety differences in stress exposure. So this is an example of Canadians in New York City with moms, there was not major psychology, but moms who had varying levels of hair cortisol. That hair cortisol predicted those patterns. So infants of moms whose hair cortisol indicated higher levels of physiological stress showed more low frequency, less high frequency power. So a pattern suggestive of maturation. I hesitate to use that term because it's not longitudinal.
So I have a question along those lines.
Yeah.
You show that the effect of low maybe alpha, beta, or delta frequencies, but up to 20 per month, and then a deficit in high frequency for low treatment. Would you expect that
So that's really unclear, right? And we don't know. So the study I showed you in our data was up to 12 months, and it wasn't longitudinal. It was 6, 9, and 12-month-olds all mixed in the bucket. We are doing a longitudinal study right now that I mentioned that's going to be following patterns from 1 month to age 3, maybe longer if we get more funding down the road. But so we'll be able to measure it up to there. I think it's not really clear whether those patterns whether it's truly a lag or a deviance, right? So. I mean, it's hard to know, right? Electrophysiologically, you can certainly see differences in brain structure that I showed you.
Sure. So, again, pretty much is, if it's true that poverty bands are really hard, and you have parents who are poor who probably also do it themselves. Is there any data showing correspondence between individual self-experience, structure, or language richness, and the responses and those of their children? How closely do those things kind of contributing genetically, but also environmentally?
Right. I don't know of a good data set to ask. I know someone's doing some intergenerational work right now that could potentially address that question. But I don't know of a good data set. And we have often been met with that question, to what extent is the parent brain explaining the children's brain? And even that doesn't really get at the answer, right? Because you're exactly right that the parents likely came from adversity too. So it's a very hard question to answer other than perhaps through an experimental design. But then you'd be changing the parent's environment too.
Your work on the middle section you presented, how early or you find the difference in her, and then there's I was curious if you or anyone has looked at that especially through across racial groups, given the differences, particularly Black mothers and children versus white groups in terms of differences in prenatal outcomes that people have attributed to wrestling sort of and birth outcomes.
It's an excellent question. So that sample in our work is definitely a multiracial, multi-ethnic sample for which we included race ethnicity as a covariate. But whether you see similar impacts across racial groups, I don't think we've looked at that.
I have a bunch of questions, and I don't need to ask if I've had some time here today, but I'm being mindful of the person who booked to meet with Kim after. I don't know, there's a competition here, so we'd love to ask more questions. Is that okay, or do you want to close these things up or walk over? Maybe you can ask some questions if you do, but thank you very much for today.